in France. That's pretty crazy. All right, so let's get started. Today we're going to be looking at the first lesson in second unit. Okay, so we're moving away from our word problems. We're moving into lots of graphs. Lots of graphs. Okay, so we're going to start with the absolute value function because we've been talking about absolute value right in the previous unit. So an absolute value function, the general form of that is y equals a times the absolute value of x minus h, finish the absolute value plus k. Okay, the a, the h, and the k are going to be numbers. Okay, they're not going to stay like variables. Okay, the a, the h, and the k control different things about the graph. Okay, so a will control direction, width, narrowness. H controls the shifting to the left and right. K controls the shifting up and down. Okay, today we're not really going to spend so much time talking about it, but just know that they mean separate things. Okay? In addition to that, when it's in general form, it's real easy to find the vertex of an absolute value function because it's simply whatever h is and whatever k is. And you literally just pull the numbers out and you get a vertex. Okay? Now, it's a little bit tricky with h because you actually have to take the opposite, not whatever you see. All right? And so it's kind of like quadratics in that sense. So, very similar. This form is xy, this form is f of x, but it's the same thing. Okay, notice how this is the same. The only thing that changes y and f of x because right, you might see it in two different ways, so just to be familiar with it. And then finally, just to recap what a vertex is. A vertex is your highest or your lowest point on a function. Okay, so it could be at the very top if your graph does something like this, or it could be at the very bottom if your graph does something like that. Okay, so again, very much like a quadratic. Ultimately, that highest or the lowest point, we call it a minimum or a maximum. All right. Questions there? No? All right. Copy it down. Make sure you're copying it down. Okay. All right. Moving on to the next one. Okay. So our first example here is going to be the most basic, not in a bad way, like a basic person, but like the simplest form of an absolute value function. Okay. And we call that the parent function. The parent function because everything else that comes from that, right, you can always go back to and refer to this as like your original function. All right, so kind of like your parent in that sense. So this is my function. The first thing I want to do when I have a function, if I want to graph it, is find the vertex. I want the vertex because not only does it tell me if it's a low or a high point, but it tells me exactly the middle of the function, just like a quadratic. Okay, so I'm looking for that middle point because then I just know I can graph to the left and to the right, and I'm going to get a very nice graph. So I'm looking for my h and my k. Now the problem with this is that even though it's in general form, there's no number inside and there's no number outside. So when that happens, okay, we can rewrite this. And would you agree with me that this is the same as this? Yes, no, maybe. Yes? Yeah, because if I take nothing away from x, I didn't change it. And if I add nothing to the outside, I still didn't change it. All I did was I put some placeholders in there because now what do I have? What two letters? I have an h and I have a k, right? So I'm able to pull these values out and then create my vertex. So usually I would say take the opposite of this and keep this. Well, the opposite of negative 0 is, well, there's no opposite of negative 0. It's just 0. Okay, so in this case, 0 is an exception, but we keep the outside always. All right, so opposite, keep. So therefore, I have a new vertex here that is going to be 0, comma 0, otherwise known as the origin. Right, so when we graph it, it's right there. Okay. All right, we have a vertex. From there, now we move on. We need 5 data values, at least today, because we're graphing kind of like the getaway, the slow way. All right. Next week, we'll find like the quick way to do it. But for today, we got to stick with this. So when you create a table of values, I like to put the vertex first, and I find it in the middle. So notice I have 1, 2, 3, 4, 5. Vertex goes in the middle. So I'm going to plot here. My x value is 0. My y value is also 0. Now I want 2 values for x that are a little bit smaller than 0, and then I want another 2 that are a little bit bigger than 0. Okay, so try to stick to the number as close as you can. So I'm going to choose -1 and -2. And then I want slightly bigger than 0, so I'm going to go ahead with 1 and 2. Okay, and that'll be good enough. All right, so now all we have to do is evaluate. We have to take our x value, plug it into the function. Remember that this is the function here. So I just copied it over here. I want to plug -2 in for x. Okay, so I'm taking this x value and plugging it in right there. So now, real simple, all I'm looking for is take the absolute value of -2, and what do we get? 2. Okay, same thing with -1, absolute value of that, 1. I don't need to do this one, it's already done, that's my vertex, keep moving. Okay, so absolute value of 1, that's 1, and absolute value of 2, that's 2. Okay, so it's pretty simple, especially with this one, because there's no other work to be done besides just turning from the input into the positive output. So now create a list of coordinate points, -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. Okay. I like to write them out side by side, right, real quick. That way I don't accidentally confuse, like, I might accidentally confuse this to be my y. I just like to take this x value and my y value, create the pair. Okay. All right. So from there, first point that you're going to plot is the vertex. Always the vertex first and then everything else after. So over here on your xy plane, okay, plot that point 0, 0. Okay, right next to it, put a V next to it so that you remember that's my vertex. Okay, because when it comes to graphing, you don't want to make the mistake of treating another point as your vertex and then drawing something that looks funky. Okay, so draw the V. I know that I'm going to refer back to that. So plot the rest, -2, 2, so 2 to the left, up 2. -1, 1, 1 left, 1 up. 1, 1, 1 right, 1 up. And 2, 2, 2 right, 2 up. Okay. So there's my overall, that's my shape. How do you graph? Okay, I like to start at the vertex and connect the lines going this way first and then this way. Okay, so that's why I labeled the V, because that's where my starting point is, and then I draw going outward from there. Okay, so let me draw something. Start from here, draw it out. Okay. Notice I have an arrow on it because this continues, it doesn't stop. And then the same thing for the other side. And there's the graph of a vertex parent function. Okay? I'm not vertex. Absolute value function. Absolute value function. Okay? So pretty straightforward. Okay, pretty simple. Alright. Questions? We're okay so far? Alright. So now, once we have a graph, we talk about domain and range. Right? So I give you a little hint there that the domain is referring to my x values and the range is referring to my y values. Domain, it's a fancy way of asking what are all of the possible inputs. Now, when you're looking at a graph, the way that I like to read domain is how far left does this graph go?
-4. Negative.
Think bigger because there's an arrow. So does it stop? No. So it keeps going to -infinity. Okay, so then from -infinity, remember that I want to read domain like from the left to the right. So if it goes from -infinity to the left to the right, where does it go?
Positive.
Positive infinity. Okay. Very nice. Since I cannot include infinity, I have parentheses around both of them. Okay, so that interval looks very familiar, right? It's kind of like what we did with our inequalities. Okay, there's another way to write it as well. Okay, this one is not so familiar, but it looks like it looks like a compound inequality, and it's very straightforward. Because the domain refers to the x value, x goes in the middle. I've already created the interval here, so I know that my maximum is infinity. So then infinity goes over here on the right. Negative infinity would go over on the left. Okay, since my domain is talking about all the values that I can be, then basically what I need is just some inequalities that say that I'm anywhere between negative infinity and infinity. So that's good enough right there. If I'm an input, I could be less than infinity but greater than negative infinity, and that literally puts me anywhere on the number line. Okay. All right. So domain is easy. Okay. Here's a cheat code. Domain is always the same for an absolute value function. You never have to worry about changing the domain. It's always this. Okay. Why? Because think of a number that you could not plug in to this. You plug in anything, right? Pi, negative 3,000. I love you 3,000, whatever. Okay. So, doesn't matter. Domain always stays the same. Doesn't matter what happens to this picture, domain is the same. The range will change every time, okay? The range will change almost every single time. So range is looking at y values, but it's looking at, instead of left to right, it's looking from bottom to top, lowest to highest. So on my range, what's the lowest y value that I see here on this graph? It's 0, okay? So don't get confused here. You're looking for y value, this one, not this one. The x can change, it'll shift around. I want to know what's the lowest value, so I'm looking for 0 on my y value, okay? So then 0 is the lowest, and now I'm looking for what's my highest. Infinity, because the arrows don't stop moving. They keep going up, so there's no limit. Therefore, they reach infinity, okay? Around infinity, always a parenthesis. At 0, can we include it? Yes, because there's actually a point right there, right, where we do have 0. So then we include this guy. That's a bracket. All right. And then we write something similar to what we did with domain, right? So for range, instead of x, I'm using y. Okay. Infinity is my upper boundary. 0 is my lower boundary. Okay. I need to be less than infinity, and I can be greater than or equal to 0. Okay, so any y value can fit somewhere in between here. So greater than 0 or equal to 0 all the way up to infinity. Okay. So two ways of seeing the domain and the range there. Okay, questions? We're good? All right. It's pretty simple. Okay, it's pretty simple. All right, let's take a look at the next one. Okay, let's practice a little bit here. Okay, so now we don't have a parent function. Okay, there's a slight change. What do you notice? What's different? The plus 3, yes. Okay, so now there's a plus 3 on the inside. We know what that 3 is going to kind of do. All right, but first I want to see if I can find a vertex here. Okay, now I don't have anything on the outside. What can I add? I can add a 0 to help me remember that I need something for k. So if there's nothing there, go ahead and add a 0. So now the two words you need to remember are opposite and keep. Opposite of the inside number, you keep the outside number. Okay? So my vertex is going to be opposite of 3, which is negative 3. And then I keep the 0, so then that's just a 0 there. Okay? So h and k. H and k. All right? Okay, so now I want to create a table here. Vertex goes the third value. Okay, I want it to be like in the middle. So then I have negative 3 and 0. And I want some values here that are going to be less than negative 3. Give me some. Negative 4 and? Negative 5. Okay. Give me some that are a little bigger. Negative 2 and negative 1. Easy. Okay? So two numbers left of it, two numbers to the right of it. Now we go in and we plug this negative 5 in for our x. Okay, so I want this value to substitute my x there. All right, so here's how this works. I take the absolute value, I plug in negative 5 plus 3. Okay, now when you have something inside the absolute value, what do you do with those numbers first? Yeah, you solve it, you simplify them, right? You combine them. So this gives me still absolute value of negative 2. And then what is the absolute value of negative 2? 2. Okay. Nice. All right, keep moving. Absolute value of negative 4 plus 3. That gives us the absolute value of what? Negative 1, which is equal to 1. All right. And we do the same for the other two. Okay, so let's do that. Absolute value of negative 2 plus 3. That gives us absolute value of, that's a 1 on the inside. okay? Because when I combine these two, I end up with a positive 1. That's okay? That still equals 1. And then finally, negative 1 plus 3 equals absolute value of 2, which is still 2. So notice that a nice little pattern is happening whenever we start with the vertex and we put that in the middle. Notice the nice little pattern we get: 2, 1, 0, 1, 2. Okay, it happened before on the parent function as well. Okay, now it doesn't mean that the outputs are always going to be 2, 1, 0, 1, 2, but there's usually a pattern where it's descending and then it increases, right? Because you have that V shape. Okay. All right. So now let me go ahead and write these out: negative 5, 2, negative 4, 1, negative 3, 0. Negative 2, 1, and negative 1, 2. Okay, and now let's go ahead and graph. Okay, which point do I plot first? Vertex. Start with that vertex, which is negative 3, 0. Okay, so let's go ahead 3 to the left and 0 up. So that's my V. Okay, then I can plot everything else. Okay, so negative 4, 1, negative 5, 2, negative 2, 1, and negative 1, 2. Okay. If I'm drawing this V shape, like where do I put my pencil first? Vertex, and then connect these 2 points this way, and then go back, and then connect the 2 points that way. Okay, make a V shape. So from here, like that, and then on the other side, same thing. So there's our graph. Questions? Easy stuff compared to word problems, I think. Danny's like, yeah. Simple. Domain, what's the cheat code? Negative infinity to infinity. Domain doesn't change. Why? Take a look. This arrow is always moving to the left, and this arrow is always moving to the right. It covers the whole thing. Okay, so negative infinity to infinity. Okay. And we can also write it as that compound inequality. Okay, so we can have x in our middle. It's got to be less than the positive infinity, but greater than negative infinity. That's those are the 2 ways we can write. Okay. All right, the range. How do we write the range? Bottom to top or top to bottom? Bottom to top. Okay, bottom to top. What is the lowest value that we have? Is it 0 or is it negative 3? It's 0, right? Because I'm looking at the y value there, the lowest in terms of the height. Okay, I don't care that it got shifted that way. Lowest is 3. I'm sorry, 0. Lowest is 0, and then it moves upwards. So then infinity. Okay. At 0, bracket or parenthesis? As a bracket because we can include that point. Okay, so then let's go ahead and write it also as the compound inequality. This time we use y. My y value, anything less than infinity, but it has to be greater than or equal to 0. Okay. Questions? Okay. All right, next one. This one I was going to let you guys do it on your own, but I want to make sure that we finish on time, so we're just going to run through it. Okay. All right. Example 3 here. Okay, now we got a couple of different changes happening. All right. If I'm looking for the vertex, however, okay, the only 2 places I look are inside absolute value and then outside. Okay, I don't really care that this negative is there. That's not going to change anything for me. Okay, I still follow opposite key. So what's our vertex in this case? Negative 3, comma 2. Okay, so opposite, we get negative 3, and we keep this guy. Since that's a positive 2, it's a 2. Okay. Now I have that. I go down 3 spaces, create a table. I have negative 3 and 2. Okay. From there, I want to select 2 smaller and 2 bigger. What should I use for the 2 smaller ones? Negative 4 and negative 5. And then for the smaller ones, we'll use -2 and -1. Okay. All right. So the tricky thing on this problem is evaluating because there's quite a lot going on. Okay, so I'm gonna plug in -5. I'll plug it in. I'm gonna do it vertically because it's a little confusing going horizontally. I like working downwards. So watch how this works. Okay, I got -5. I'm gonna plug it in for x. Okay, let me show my scratch work over here on the side. So I have a negative, which is part of my function. Okay, this part right here, you see that? That's what I copied over. Okay, so I need that negative. Don't forget it. Okay, copy it over. Then the absolute value of, I'm gonna plug in -5 plus 3, and then I have a plus 2 on the outside. Okay, so going back to how we approach something like this, first of all, you never distribute the negative because it's not parentheses, it's absolute value. It's jail, right? Nothing comes in. So you have to clean up the inside first. -5 plus 3, what does that give us? That's a -2. So we get the absolute value of -2. Okay, bring down the plus 2, and then my negative, bring it down in front. Okay, but I'm still not using it. Then, what's the absolute value of -2? That's a 2. Okay, so the 2 comes down. Now, the negative is going to come with it. Now it drops. Okay, now we can bring that down and we just say that's a -2 now. And then we add 2. So what do we get?
0.
We get 0. Okay, so that's our output for -5. 0. Okay, same thing with -4, -2, -1. Try it. Okay, and then let me know what you guys get. Anybody find the y value when x is -4? 1. Okay, good, good. We got 1. Okay, what about when x is -2? It's also 1. What about when you plug in -1? 0, right? So, nice little pattern, right? But it only works when you start with vertex and you find numbers a little bit bigger and a little bit smaller. Okay, if you would have done vertex and then you choose -2, -1, 0, and 1, you're not going to get that pattern. Okay, it only works because that vertex is the middle, and then everything else from that, it was going to make it symmetric. So you're going to get the same outputs. Okay, all right. So let's go ahead and plot these points. Starting with vertex, I go to -3 and then up 2. So I'm right here. Label my vertex. Okay. -4, 1. -5, 0. -2, 1. And -1, 0. Okay, so from there, it's a little different, right? I have my vertex now, it's at the top instead of at the bottom. So this is why I like to label it, because that reminds me, okay, that means I put my pencil here and then I connect down, right? Same thing here. So starting from my vertex, connect the points downward, do the same thing to the other side. And there's your graph. Okay, so how is it different? The arrows are pointing downward, right? So instead of opening up, now it's opening down. What do you think caused that change? The one out front, right? That negative. Usually what do negatives do? They turn it into the opposite, right? So instead of pointing up, now it's pointing down. 3, we already kind of saw what it did. Which way did it move it? Left, right? It's not what you expect because it's a +3. You might think, oh, it should move to the right. +3 is over here, but it's not. It moves the other way. And then the +2, what did it do? Up. Okay. So that's kind of what we're going to take a look at next week. We're going to spend a little bit more time as to how to identify what the changes are without even having to graph it, so that you can already create a mental picture in your head what that graph is going to look like, and then this moves so much quicker. You don't even have to do the whole tape. All right. Okay. Before we leave, let's talk about domain and the range. What's the cheat code for domain? Same thing, man. It's the negative infinity to infinity. Man, women, boy, girl, people. Okay. Looks the same way with an inequality as well. All right, now the range. How do we measure it? Lowest to highest, highest to lowest. Lowest to highest. Okay, I know it's weird. It's like your mind wants to think like highest to lowest, but it's gonna have you write it. If you do highest to lowest, you're gonna write a range that's like backwards. So think bottom to top. Okay, it's like you're measuring something from the ground up, right? So the lowest in this case, if it keeps going forever, what is that lowest? Negative infinity, right? This arrow is gonna keep going downward. So from negative infinity, what is my highest y value? It's 2, right? My vertex. Okay? So that's why I like to label it and put it, because then I just refer to the picture instead of having to look over here on the table. Right there, that's a 2. So at infinity, parenthesis, at 2, bracket, because we actually have a point at 2. Real quick, y value this time. My max is a 2, my min is a negative infinity. So those are my boundaries. I want to be less than or equal to 2, right? Everything below or equal to 2. And I want to be greater than negative infinity, right? So above negative infinity. So there it is. All right. Any questions? No? All right. We'll keep going next week. No homework this weekend. Take a break. Okay?